Hi, everyone. My name is Dom Ceruzzi, and I'm a graduate student at the University of Wisconsin in Madison. And today I'll be sharing some of our work on monitoring tree sway as an indicator of interception processes. In this first panel, I provide the overall key points of this work, a definition about rainfall interception, knowledge gaps about interception uncertainty, and the overall research objectives of this work, which were to determine whether tree sway period changes over a storm, to determine whether canopy water storage is uniquely related to those changes in tree sway period. And we also wanted to evaluate the feasibility of using accelerometers to monitor changes in canopy water storage throughout a storm. The second panel shows our conceptual model and methods, including how we evaluate changes in canopy water storage through our experimental design, and some concepts related to tree sway period. In particular, we think that the tree sway period should elongate as canopy water is gained in the canopy, and that tree sway period should shorten as that canopy water is lost from the canopy. And these overall changes in canopy water storage drive changes in tree mass, which drive the changes in tree sway period. This third panel presents the results of this study, including a representative storm where we track the partitioning of precipitation into its components, including this blue line, which shows the changes in canopy water storage, and this red line, which shows the changes in tree sway period. We further analyze these data and show an aggregated response of 4 trees across 5 storms, and we separated these data into drying and wetting phases. We observe an interception-related hysteresis effect between wetting and drying cycles that are captured in tree sway responses, which we think might be attributed to changes in the redistribution of that water during and following a storm. In this fourth panel, we discuss the implications of this work, which include continuous monitoring of tree sway, we think can identify and evaluate tree interception processes. We also think that this canopy redistribution of water during and following a storm as tracked by tree sway motions is important to consider. We also think that this approach could be useful as a tool that can monitor, quantify, and evaluate holistic tree responses to interception processes, which might be well suited to evaluate green infrastructure practices and stormwater management. And some of the future directions of this work include testing this approach for scalability and the robustness. This last panel summarizes this research and provides the acknowledgments to this work. And with that, thank you for listening, and I'd be happy to discuss any questions or comments that you may have. Thank you.